Hey everyone, good morning. Now we are going to solve second question of today's Leetcode weekly contest 438, which is maximum sum with at most k elements. So let's see what is this question and how we can solve it. So in this question you are given a 2D integer matrix grid of size n cross m, an integer array limits of length n and an integer k. The task is to find the maximum sum of at most k elements from the matrix grid such that the number of elements taken from the ith row of grid does not exceed limits of I, and you need to return the maximum sum. So what you have been given in the question is a grid of size n cross m and a limits of size n and an integer k, and you need to find the maximum sum of at most k elements from the grid such that from a single row you cannot take more elements than this limits of I. Okay, so let's see. You have been given with this grid 1, 2, 3 and 4. So this is 0th row, this is first, this is 0th row, this is 0th column, and this is first column. And you have been given with the limits 1, 2. So from the first row, you cannot take more than 1 elements. From the second row, you cannot take more than 2 elements. And you need to find the sum of at most, maximum sum of at most k elements, that is 2 elements. Okay, so from the first row, we cannot take more than 1 element. So if we cannot take more than 1 element, then the element which we can take, we will try to maximize that element, right? Because we need to maximize our sum. So if we can take only single element among 1 and 2, so what we want to take, 1 or 2? Obviously 2, because we want to maximize our sum. Okay, cool. But how we can take the maximum element from this row? Okay, so what we can do, we can sort this row in a descending order, that is 2, 1, and this row as well in descending order, or we can say all the rows in the descending order. Why? Because we can take only a limited number of elements from a single row, and if we can take only limited number of elements, then we want to take the elements which are maximum, because we want to maximize our sum. Okay, so let's start taking. Okay, so we can take one element from first row. Okay, so we will take one element. Okay, so we can take two elements from second row. Okay, so we will take two elements from second row. Okay, but our k is 2. It means from this complete grid, we can take only two elements. But we have taken 3 elements till now. Now among these 3 elements, we need to take maximum 2 elements. Why? Because we want to maximize our sum. Okay, now what we can do to take the maximum elements from these elements? So what we can do, we can store these elements in a max heap. Okay, so if we have stored these elements in a max heap, then we can simply pop out top k elements from the max heap, so we will get maximum. Okay, so if we will pop out k elements from this max heap, then what we will get? 4 and 3. Okay, now we have got our k elements whose sum is 7. So this is the maximum sum of this grid. Okay, cool. Now let's see another example as well to understand this question better. So grid is 5, 3, 7, 8, 2, 6. Cool. This is 0th row, this is first row, this is 0th column, first and second. Limits are 2, 2. Okay, limits are 2, 2. Okay, now what we are doing to solve this question is, first we are sorting all the rows in the descending order, because we can take only a limited number of elements from a particular row, and we want to take the maximum elements as we need to maximize our sum. Okay, so let's sort all the rows in the descending order first. Okay, cool. Now we can take two elements from the first row. Okay, let's take maximum two elements, that is 7 and 5. 7, 5. Now we can take 2 elements from the second row as well. So let's take maximum 2 elements, that is 8 and 6. Okay. Now we can take only at most 3 elements to maximize our sum. So we will store these elements in a max heap and we will pop out top k elements, which are 8, 7 and 6, whose sum will become 7, 8, 15, 6, 21. Now our maximum sum is 21 of top k elements considering these limits. Okay, yes, we have got our output. So what we need to do is we need to sort all the rows in a descending order. Take limits of elements from each row, store them in the max heap and pop out k elements from the max heap to get our maximum sum. Okay, now let's try code this so you will get a better idea. So let's initialize our n with grid of size, m with grid of 0 dot size, and what we need to do, we need to initialize our max heap priority queue int. Okay, now we will start iterating in our grid. Okay, now what we need to do, first we need to sort all the rows in a descending order. So what we will do, grid of 0 dot r begin, as we need to sort them in a descending order, so that's why r begin. Grid of I, it's I not 0, as we need to sort all the rows, r dot end. Cool. Now what we need to do, we need to take out limits of I elements from each row. Okay, int of j equals to 0, j is less than limits of I, j plus plus, and we need to push these elements in our priority queue, that is grid of I, j. Cool. Now what we need to do, let's initialize our max sum with 0 and we need to pop out top k elements from the queue until the queue becomes empty, and add those elements in our max sum pq dot top, and let's pop out from the priority queue, and finally we will return our max sum. Okay, let's try run this. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexities as well. So first we are using this loop for iterating in the complete grid. So we go of n, and then we are sorting each row in a descending order, and each row contains m elements. So sorting complexity will be m log m, and then what we are doing, we are popping out elements from our priority queue, and our priority queue can contain at most m cross n elements. This means our priority queue contains at most all the elements which the grid contains. So our priority queue contains m cross n elements, and we are popping out only k elements. So it will become k into log of m into n. So our overall time complexity will become n into m log m plus k into log of m into n. And our space complexity will be m into n, as we are using priority queue which can store up to m into n elements. So yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.